Mr. Abbott here, and time for another boring activity explanation. This one is on determining the epicenter and magnitude of an earthquake for 2019. This is activity number 43. Essentially, we have a map of California and surrounding states with a map scale underneath. You know we're going to need 3 locations to locate the epicenter. We're also going to see how you can use the magnitude of the S wave, the highest amplitude of the S wave, and the distance to determine the Richter magnitude using what's called a Richter Nomogram. So if you flip to the back page, you'll see we have the seismograms for this activity. There's 3 locations: Eureka, Elko, and Las Vegas. What's nice is they put the P wave exactly at 0. So the 2 things we're determining from these seismograms is the difference in arrival time between the P wave and the S wave. That's also sometimes referred to as the lag time. And then the maximum amplitude of your S wave. So for the first station here for Eureka, the P wave is always going to be at 0 for this activity. So the S wave is at 50. So I'm getting a lag for this one of 50 seconds, which you'll record on the other page on the chart. To find the magnitude, the S wave comes second because it's slower. It's a transverse wave, but the maximum amplitude isn't usually the first one. If I look here, this displacement is the highest. I come over and looking at that value, I'm looking at the scale. Those numbers are going by tens. So to me, it looks like the height of this is 3 up. So for the magnitude of the S wave there, I'm getting the highest value as 280 millimeters. So we're recording that data onto the chart under step 2. We've got a 50-second difference, and then the maximum amplitude for the S wave was 280 millimeters. So this column is the lag between the P wave and the S wave. To find the distances, traditionally we would use the P and S wave chart on the Earth Science reference tables, but these are closer to the epicenter. So what you're going to have to do is you're going to need to use the chart that's provided with the lab. So this chart is going to be here next to the Richter Nomogram. So you have a P and S wave travel time graph over here, and then you've got the Richter Nomogram chart on this side. So what's nice about this particular graph is they've already calculated this line is the S minus P. So when you're looking at this, I'm just going to label this as the lag. That's the separation between the P and the S wave. So we use this one to find the distance, and we're going to use the Richter Nomogram to find the magnitude. So for our first example, there was a 50-second difference. So 50 seconds is here. I have to read this across until it hits my line for lag, which is right about there. That's between 480 and 500. So I'm going to estimate that value based on the 50-second until it hits this line. You read down, and we're going to get 490 kilometers. Now that I know it's 490 kilometers from the epicenter, I can go back to the first page of our activity or the first page of the chart, and then we can plot out and draw a circle of the correct radius. So when we're looking at the front of the graph, here's my chart. I'm going to look down at the scale on the bottom. I have to estimate between 400 and 500. I'm going 1/10 of the way there. I'm putting a mark. So this is going to be my first distance that I'm estimating as 490 kilometers. We have to use our safety compass for this. The way that I prefer to do this, although there are different methods, is I physically like seeing the line through the hole. So we're going to line up. So the center here is there. I'm going to slide this across until I see that my mark on the scale is directly in the middle. And then I just like to make a mark with that to see that my circle is right hitting that point at 490 kilometers. So 490 kilometers is definitely the distance from Eureka. So Eureka is here. Looks like I'm not going to be able to get the full circle on the map, but that's okay. I'm going to place the dot of my safety compass right on the point for Eureka. I'll put my finger in the mark, and then I'm just going to simply cut an arc through this, and that's going to be a radius. And sometimes I like to do this. I'm going to mark that radius is from Eureka. It was 490 kilometers from the epicenter. So my first circle is there. My epicenter could be located anywhere on that. Now, to use the Richter Nomogram part, I've got my height of the S wave, the maximum amplitude or height is 280 millimeters, and my distance is 490 kilometers. So I'm going to go to my Richter Nomogram, and my Richter Nomogram, of course I can't find it, here we go. My Richter Nomogram is here. So I've got 2 points that I have to plot. My distance was 490, so these are going by 20s. So 490 is going to be halfway between 480 and 500. And the amplitude in millimeters was 280. Now, these scales are logarithmic, it looks like. Okay, these are going by ones, but up here, these are going by 20s. Okay, these are going by 100s. So between 100 and 200 and 300 is 280. So 280 should be a point right there. So we plot the distance on one side and the amplitude of the S wave on the other. Then we're going to take our straight edge, and it's nice that the safety compass can also be used as a straight edge, but I'm going to draw a line and connect those points. And when those points cut through the scale in the middle, that should give me an idea of the magnitude. So that first line represents the values that we should have gotten from Eureka. Now, all you have left to do is to repeat that process for the next two locations. I would like you to pause the tape now and try those, and then restart the tape so we can compare the answers. All right. Based on your calculations, Okay, you should have gotten approximately these values for Eureka. We did that together. Elko was a 72-second lag. That was the 60 was the amplitude, and I got 700. Las Vegas was 64 seconds and 100 millimeters. So when I did that calculation, I got 620. Constructing all three of the Richter nomograms. Okay, this was the chart that I got using those distances, and you can see that for all three of them, they made a nice intersection. So we recorded the magnitude of our earthquake as 7.1. So sliding down, okay, you should have gotten a magnitude for this earthquake of 7.1. If you got 7.0 or 7.2, there is some variation in this. Now, for the location of the epicenter, you need to draw all three circles. So when you construct all three of your circles, okay, from Elko, I got 700. From Las Vegas, I got 620. When I constructed them, I was lucky. They came together at one nice point. So I put an X at that point and labeled it the epicenter. If you get a small triangle here, that's certainly appropriate. So hopefully for that last question that you have, which city was closest to the epicenter, they're not asking you of the seismograms, but which city. It appears like this earthquake was centered near San Francisco, which honestly makes sense because you have the San Andreas Fault running through California to transform plate boundary. I hope this helped you complete the activity. Good luck.